Two circular discs of diameter 20 centimeter are placed 2 meter apart. Calculate the radiation heat exchange of for this disk if these are maintained at 800 degrees Celsius and 300 degrees Celsius respectively, and the corresponding MCT of the two discs are zero point 0.3 and zero point 0.5. So we have to find simply the radiation heat exchange of these two discs, which is kept 20 centimeter 2 meter apart, and they both are in circular. They both are circular disc, and just have to find the uh, radiation heat exchange between them, and the corresponding MCT is also given. So how to solve this problem? So now to solve this problem, uh, we have to apply the same formula of parallel disk. Okay, parallel plate and parallel disk, we have the same formula because we have the question, we have similar case to parallel disk which is kept some meter apart. So obviously, uh, every heat transfer or any amount of radiation passing one plate would fall on completely on the other plate. Okay, just kept parallel to each other, even though they haven't mentioned parallel, but the two discs of same diameter, they already mentioned two discs of same diameter, just kept some meter apart means it is obviously parallel. These we have to guess that. So for we have to apply the same formula for parallel plates or parallel disc. That is the general equation for two discs which is parallel to each other. Q is equal to sigma A T1 raised to 4 minus T2 raised to 4 whole divided by 1 by epsilon 1 plus 1 by epsilon 2 minus 1. Where epsilon 1 and epsilon 2 are the emissivity of the two corresponding plates, and T1 and T2 are the temperature of the two plates. So our next aim is to find the parameters needed to substitute in this equation. Okay, here I have written what are the different parameter. Q is heat exchange, and sigma is obviously the Stefan Boltzmann. It's a constant value. You have to learn this value, which is 5.67 into 10 raised to minus 8 watt per meter square Kelvin raised to 4. Okay, then A is obviously area of the disk. Both the disk have the same area. Uh, then the T1 and T2 are the absolute temperature. You have to convert into Kelvin. In the question, it is given in the Celsius, so it has to be converted into Kelvin. So just add to 73.15 to the given temperature. You will get the corresponding temperature of both the disks. Then find the area of the plate. We have the diameter, just converted in meter, so got area of the plate. So I got all the parameters substitute for this equation. So next step is simply substitute all this value into this equation, and you got the heat exchange between the two plates.